Okay, so what we'll be doing for the next 30 minutes is we're going to take a little bit of a step back to talk about the overall MES solution that Proplanner provides, do a quick demonstration of some of its capabilities with a focus on data collection. We'll take a look backwards, reflecting on what was completed in 2020. Then we'll also go through the roadmap for 2021 and hopefully spark some discussion with that. So first, speaking with you today. So again, I'm Dan. I'm an account manager with Proplanner, and I've been here just coming up on 7 years now. And really start with this bullet at the top here. So this is what you'll see if you go to Proplanner's website. It says tools for teams to launch complex products to the factory floor. I added some text there that says and build complex products, because really our MES solution is all about taking that rich process data set and acting upon that. That can mean pushing the data out to downstream subscribers like ERP systems, third-party MES systems like the Pivotware tools, as well as Proplanner's shop floor viewer, which would be its more the actual application name. So this problem that we're trying to solve, really at the core of Proplanner, is this manufacturing process management data set. How are you maintaining this data set, this information around your manufacturing process plans, designing what's going to happen, what tools do you need, what parts do you need, what information do you want to display to the operators, and making sure all that information is synchronized with when your product as well as process design changes need to go live on the shop floor. As I'd mentioned on the opening slide here, this is intended to be more of an overview. I have the schedule over on the right-hand side, and you can see we've had a lot of different presentations today that have touched on aspects of some of the execution capabilities, but we're going to take a little bit of a broader look today. And for those that are not familiar, the typical users of Proplanner's shop floor system, I would say the people that we've seen they've gotten the most value out of it, would be those manufacturers that are really in the high mix environment with a relatively low volume. And I'm careful with putting labels on that. It can be a little bit dangerous. Low volume can mean lots of different things. Takt times from a couple of minutes up to many days. We also find that there's some overlap then with companies who have some sort of regulatory or a customer-driven compliance requirements where they have a lot of data collection and they need to be really sure that they've collected the right as-built data on the shop floor and that they have timed in the process plans for the unit that again synchronizes with the product and process design changes. So Proplanner's been working on this, as Bondo mentioned during one of the presentations earlier. We've been working on this for really over a decade, this display of information to the operators on the floor. We've made lots of progress with this MES solution, but it is not something that is a solved problem by any means. So that's really my goal here, in addition to presenting information about what our tool is able to do today, and again, what we've done over the past year, but also looking forward. Here's the plans that we currently have, and then making sure we're getting your feedback on what you would like to see to be more successful on the shop floor in the actual execution system. So first, we spent a lot of time today talking about the shop floor viewer. We've done some demonstrations, but what I'd like to do is just walk through a demo that goes through the operator experience from sign-on, notifications around the fact that there are changes, viewing the configured work instruction. We'll go through and actually collect some data by executing some checklists. We'll also denote a component serial number against the unit. And then we'll go through the process of raising a defect, walking through some repair actions, and then ultimately raising a non-conformance for the part that had an issue. Okay, so opening up my shop floor viewer. First thing I need to do is I need to tell the system who I am and where I'm working. So I'm going to identify the line, station, and then the operator position at the station that I'm fulfilling. Then I'll go ahead and log in. I'm in admin mode, so I'm effectively seeing everything. But this screen, as well as the other screens that we'll look at within the application, are all configurable based upon the user role. So Brett really talked about this when he got into Terex and their experience between Assembly Planner and the shop floor viewer, where Assembly Planner, the process design system, is really the engineering toolkit that we want to use to, again, provide as much flexibility for process design, for exploring how you could improve your manufacturing plans. But on the shop floor, it's very much dependent on your role within the system, and particularly for operators and trainees on the floor. We want to make the information as digestible and the actions that you need to take, or that you can take, as obvious as possible to limit, obviously, the amount of mistakes as well as the amount of training that's needed. So let's take a step back to where we're actually at within this workflow. So I've told the system where I'm at. I'm at a station, and I'm ready to do some work. A new tax cycle has started, and I need to tell the system this is the unit that I'm about to build. That signal could come in through barcode scan, could come in through an RFID reader, but some way, somehow, I'm going to tell the system I am working on this VIN number or this particular production order. I'm going to go ahead and click sign on to VIN number 1. And then what Proplanner is going to do live is we're going to evaluate based on the fact that we know who is working, what they've done in the past. We're then going to look at the instruction that this user will need to complete specific for the configuration of this VIN number that's in front of us. And we can see that there are 2 different change notes that this user needs to sign off on, or they need to acknowledge prior to actually completing the work. And we're not going to let them do anything against the unit until they have acknowledged this. So I'm going to go ahead and acknowledge that I've at least read these, then I'll move forward. Now I've gone into a screen that's called the process tree. And what the system is doing here is it's giving me a preview of both the work that needs to happen in the future, as well as it's giving me status information for work that has already been completed. And here I'm starting from scratch. I'm the first station, first operator, so I need to get into it. I can select the activity, and then I can select sign on. And as we're doing this, we're beginning to record lots of data around what the operator is doing. This is a demonstration activity that I use to show some of the different input capabilities of the tool, as well as demonstrate that it can show you information about the parts that need to be installed. And then based upon the configuration settings of the tool, or of this particular screen, we can control which of the tabs displays and the overall look and feel. So here I can see that I can have a group of different work steps that need to be completed. I can see a list of the different components that need to be installed, aggregated by the parent assembly, as well as I can see the list of tools that I need to complete this process. Over here on the left, probably most obvious, I can see the images associated with the steps. And as I move through the steps, the system is going to highlight the specific work step that that image is associated to. Here, what I can do is I can provide some direct numeric inputs. I also have basic checklist controls for pass fails, yes, nos. And then we really won't get into deviations during the discussion today. But if I need to associate that a deviation should be tied to this particular unit, I can do that through this data collection control. When I click the next button, the system is going to validate all of my inputs. It's going to make sure that we are cleared to complete the next activity and we're good to go. This activity has 2 different types of data inputs. This requires that I enter information about one of the parts that needs to be installed. I need to scan the part number. I also need to input the serial number of that particular component. And down at the bottom, you can see highlighted in blue, it's showing me that I need to use this 1 5/8 inch torque tool that has a target and a range that it can hit. And this blue highlight is intended to be associated to this blue highlighted part number that I can see up here. Now this is the manual entry mode, where really any USB or serialized device could enter the data into this text field. I'm going to go ahead and enter my value. Okay, so now the system's going to validate all my inputs, so on and so forth. We move to the next activity. If I jump back to my process tree, I'm able to see the overall build status. Green means good. So I've completed my first two activities. And then I have started the build for the subassembly of the transmission, but I have missing components. So this is being flagged as red at this time. What we're going to do now is we're going to say, well, the operator bailed out to the process tree because they identified that something is wrong. And what I'm going to do now is I'm going to raise a test failure. You'll notice that on the process tree, I have a number of different tabs here. The first tab is displaying the overall list of components that are currently installed on the unit, as well as all of the other components at this station that will need to be installed on the unit. So we're building up that as-built MBOM as we go. We also have the other tabs for test failures that we'll look at here, the deviations that have been associated to the unit, general roadblocks, which is just a thing that's preventing something from occurring, as well as skipped activities. Let's take a look at these test failures. I'm going to go ahead and file an exception categorized as a test failure for the station that I'm currently on. This test failure will be given a unique and tracked ID. I can go ahead and input the failure code associated with this failure. And then what I can do is I can track the individual actions that it takes to resolve this failure. First, I can say, well, we'll use this example here. What we're doing is we're having the operator enter the component that they had to adjust. That is my action code. And here I entered some sloppy data, right? I pounded the keyboard or whatever. And we can see that, well, that component is not installed on the unit. And the system is going to flag that the operator attempted to denote that they adjusted a component that's not actually on the unit. So we had a data input failure. But that we feel that that's important because we want to describe what work is occurring against this particular unit and the components that we're actually touching. That's an important validation. I'm going to say that I'm actually just adjusting that part. This is a part that's installed on the unit. And the system here is telling me that that particular component that I'm adjusting is serialized, and it was installed at this particular station via this activity, and I can enter some comments if I would like. Now I'm going to go ahead and save that. And the system is now picking up that I've done something. I've made an adjustment to the unit, this particular component. Now, if I would like, I can actually perform another test. Maybe I get a pass, maybe I get a fail. But instead of performing another test, I might see that that adjustment did not fix my issue. I can tell that because I'm an experienced operator. I need to perform another action. So now, instead of just adjusting that part, I'm actually going to replace it. Again, I will input which component I'm working on. Ideally, I'd be scanning a barcode that is on that component. Because I'm doing a replacement, the system is saying, hey, okay, we're replacing a serialized part. We need to give it a new serial number. And because of the fact that I'm removing serial number DM1234 of this component, it could be that there's something wrong with this, and I should not use that serialized component on another unit. And I, in fact, want to raise an NCR about the old serial number as I'm in the process of replacing it with the new serialized component. I can go ahead and press save. So the system is now doing two things. It's validating that my new serialized part, 1235, is good to go and can be used on this unit. And it's also verifying, or filing the nonconformance associated with the original serial number, 1, 2, 3, 4. From here, depending on my role within the system, I have the ability to then complete some different actions as a part of this tracked test failure object. What I can do is I can actually say, well, this thing cannot be actually finally signed off unless I have the ability to promote this thing to a completion status or to a review status. So maybe I'm a repair operator and I can promote to a review state, but the repair operator is not privileged to promote to complete, and that has to go to QA. So you can imagine that via these events, we have the ability to then provide different users with different work queues. So now if I'm in a hospital or rework station fulfilling the QA role, I come to the process tree, and I'll then see the status of the various test failures that have been filed, and I can see those that are in the review state. That's my work queue. I need to evaluate the work and then bump it to complete if it's good to go, or demote it back to an in-process state and send it back to the repair operators. So that non-conformance that we'd filed, now noted over here, waiting for the non-conformance workflow to be completed within Proplanner so that you can then really initiate the disposition review process or the creation of the disposition for that individual component. Okay, so that is what I wanted to go through as far as the quick demonstration, some of the shop floor viewer data collection capabilities. And we'll go ahead and jump back into PowerPoint. Okay, so take a step back here and reflect on the work that was completed in 2020. So at the top, really summarizing the major themes if I look at what we worked on over the past year. And the first is consolidation, meaning we took different branches of the shop floor viewer that kind of specialized in different functionality, and we brought those together under one common main branch. And as a part of that work, we also enabled single sign-on capabilities, actually both on the assembly planner side as well as on the shop floor viewer side, really pushing the authentication of the users into the system outside of Proplanner into your corporate IT groups, really, so they have control over who can get into the system. And as a part of this, we also significantly modernized the technology that's being used, moving to what's called an Angular technology. So I group all of these together because they were really completed in one push. And those of you that are using the shop floor viewer today, either with single sign-on implemented, or even the older branches that's undergoing its last and final builds here over the next month, what you would have been able to see is that we were able to introduce many features that were sprinkled across many different branches. We were able to bring those into the common main branch and deploy those to many different companies. So really kind of enhancing the different capabilities that were out there. So I have listed at the bottom a wide number of the major changes that were implemented over the past year, some of which that were part of the consolidation, and others that were brand new features that were introduced for the past year. And I bucketed these into 4 different themes. So the first theme, looking back over the past year, was related to improvements in the overall just work instruction, kind of that core capability within the system. We've improved our ability to link out to external systems in a couple of different ways, but notably providing a per component hyperlink back to some external system if you need to get some part-specific data, maybe a drawing that is not within the Proplanner system. We've also added a number of extensibility capabilities in terms of being able to adjust when you look at reports, which fields you want to see, which fields you want to have both on your main work instruction screens or different exports that are available within the system. And then we addressed, I think, one of the kind of common pain points for people that utilize the single work step per page view, as we call it, so that we're kind of consolidating the parts list so that you don't seem like you have a duplicate parts list. So we hide the basic parts. We did quite a bit of work last year related to kind of bi-directional communication of the work instruction data sets, both developing an API for third-party tools to be able to call to request that a specific work instruction screen be displayed using our same shop floor viewer technology, and also to dump out the data for third-party systems for wearable devices like Proceedix, as Dave discussed early on. The next bucket that I'll hit on is related to kind of process tracking and what the operator is doing, again, from a process standpoint, which is kind of different in my mind from the serialization and history collection about the unit itself. So we've added more capability to control kind of how you navigate within the system, which screen you go to after you click sign off or after you sign on via the build list. Really the theme here, both with the navigation controls as well as process tree configuration and just the overall custom field extensibility, is we're trying to take the configuration of the system out of the code and into things that are configurable either by the system super users via the admin screens or by somebody like myself as I kind of help you with the configuration of your system. Trying to make it so it's a no code based modification that can drastically modify the user experience and how different types of users within the system are able to navigate your data sets. Finally, one of the big ones that was actually originally developed, frankly, due to security requirements, we migrated the old Windows mobile PFEP application for Kanban and kitting execution. We migrated that over to an Android-based system, and now that's it's just a much more modernized and much more secure way of executing that process replenishment. Shifting over into some of the as-built data collection about the unit itself, hit on a couple of key points here. So we have kind of uniquely in Q3 of this year developed a workflow with one plant in particular that had a need for operators to be able to select or associate option codes to a unit at the station. That's a need that in nearly 20 years we hadn't seen before. There's always new things that come up for sure. But we really are now enabling operators to select certain option codes at the sign-on process to adjust the configuration of the unit and therefore the list of parts, tools, and activities that they'll need to complete. We also completed a major project related to archiving based on snapshots of the unit BOM and the overall unit configuration, and then moving that data to a Cosmos DB located on Azure. Finally, there was quite a bit of work over this past year, as we just had a whole presentation on, related to integrating with this pivotware system to feed a robust MES tool with the process data that it needs to complete the process. Finally, on the issues management and QA side of things, as we discussed in the call earlier today, we have completed the deployment of the Andon system as a part of the FactBoard application. And I think you'll be seeing, as I'll touch on the next slide, more work this next year that improves the kind of upfront configuration of that system, the portability of data between the shop floor viewer and FactBoard, and just really making FactBoard more of a kind of a core functionality within the system. Okay, so looking again at the 2021 roadmap. So the Angular migration work is actually being completed as we speak, moving over some of the remaining dashboards that exist within the shop floor viewer. What that will mean is that for all builds, starting in Q2 of this year, you won't be seeing the ASPX pages anymore. So the shop floor viewer is going to have the same unified look and feel across the board. That was driven just as a part of our general work in terms of maintenance of the system, but also via the information security requirements, as I'd mentioned, when we talked about the consolidation and single sign-on. Dave hit on this quite a bit in the morning, but security is just the underlying theme that is really driving lots of changes within the system. Then I have 4 bullet points here to really get at changes that we're going to be making. I see primarily in the first 2 quarters of this year. First one being plugging in a virtual build CAD viewing capability into the shop floor viewer. That's come up a couple of times today. We are also going to be migrating some of our MCO approval workflows, specifically for work instruction release and approval processes, to a web-based system built upon our existing shop floor viewer architecture. Additionally, increasing the capability for generating PDF-style reports and data dumps out of the shop floor systems. And as I'd mentioned just a minute ago, a more robust relationship between the shop floor viewer and FactBoard for overall line statuses as well as and-on capabilities. And then I have the big one at the bottom, kind of a couple dots later. Timing is a little less clear on this one. As Dave mentioned, it's a kind of major focus for him personally this year. But this more direct relationship between devices on the floor, that torque tool integration via the open protocols, and just the overall strategy related to the Internet of Things. And then the big one that I'm kind of thinking about all the time and really just trying to get as much feedback as possible. Obviously, today's not the right forum to dig into this, but we just want to open it up to, what do you want to see to be more successful in your organizations, in your communication and to the shop floor and collection of data to the floor. To make your operations run more smoothly, right? That's kind of the end game here. Things like better communication of what skills are needed to do the work, tracking of training, communicating documents, SOPs to the operators on the floor that are outside of the work instruction. Even Brett touched on during his work instruction review, the ability to associate images related to defects or change requests. Those of you that have used the Pivot Grid export tool inside of Assembly Planner, it's something I'm personally very optimistic about, that overall workflow and toolkit, bringing that to the shop floor. And then finally, one that we've been kicking around quite a bit over the past couple of months is having kind of predefined routings related to repair workflows. So lots of stuff going on related to the MES system and that communication of the process data to the shop floor and feeding that shop floor data to other subscribers. So hopefully this was helpful in understanding where ProPlanner's been and where we're going over the next year. Okay, so open it up for any questions at this point.
We don't have any raised hands now, but we did have a question in the chat from Kyle.
Okay.
Kyle asked if you were able to attach 2 tools to an activity, specifically torque wrench and backup wrench.
Got it. Yes, you can. You can do that. And I think it'd be good to work through with Kyle and kind of how he wants to view the instruction. Because I think where our questions come in is, okay, in Assembly Planner, you can model that, no problem. How do you want to communicate that to the operator so that it makes sense to them? And what does it look like on the shop floor viewer? So that's a great point to bring up.